Spin-tight is not a generally recognized term in electrical engineering standards or specifically within the nuclear power field. The question likely pertains to spin-tight connectors. Spin-tight connectors are a type of electrical connector designed to create a secure and reliable connection between electrical wires and equipment or enclosures. The key feature of spin-tight connectors is their design, which allows them to be tightened to a specific torque value. This controlled tightening ensures that the connection is neither too loose, which could lead to arcing and failure, nor too tight, which could damage the wires or the connector itself. The proper torque specification is critical for achieving optimal performance and safety. Firstly, understanding the construction of spin-tight connectors. Spin-tight connectors typically consist of several components. These include the connector body, which is usually made of a conductive material such as copper or aluminum alloy. There's also a tightening mechanism, such as a nut or screw, that allows the connector to be secured to the wire and the equipment. Many spin-tight connectors include a pressure plate, a similar element that distributes the clamping force evenly across the wire, preventing damage. Secondly, examining the installation process of spin-tight connectors. The installation process involves several steps. Initially, the wire needs to be properly prepared by stripping the insulation to expose the conductive core. The length of the stripped wire should match the specifications provided by the connector manufacturer. The stripped wire is then inserted into the connector. After insertion, the tightening mechanism is engaged. It is crucial to use a torque wrench to tighten the connector to the specified torque value. The torque value is usually provided by the manufacturer and should be carefully followed to ensure a proper connection. Thirdly, talking about the advantages of using spin-tight connectors. There are several advantages to using spin-tight connectors. One significant advantage is the reliability of the connection. When properly torqued, spin-tight connectors provide a secure electrical path, reducing the risk of loose connections, arcing, and overheating. They offer consistent performance. By ensuring that each connection is tightened to the same torque value, spin-tight connectors help maintain uniform electrical performance across all connections. They are also durable. These connectors are often designed to withstand harsh environments, including vibration, temperature variations, and exposure to corrosive substances. Fourthly, considering the applications of spin-tight connectors. Spin-tight connectors are used in a variety of applications. They are used in industrial equipment, electrical panels, and machinery, where secure and reliable connections are essential. They are also used in critical systems such as control panels, power distribution units, and safety circuits. Fifthly, discussing the torque specifications and measurement. Torque specifications are a crucial aspect of using spin-tight connectors. The torque value is typically specified by the manufacturer and is usually expressed in units such as pound, inches, or Newton meters. To ensure that the connector is tightened to the correct torque value, a calibrated torque wrench should be used. It is important to regularly inspect and calibrate torque wrenches to maintain their accuracy. Sixthly, talking about the common issues and troubleshooting. Despite their advantages, several issues can arise with spin-tight connectors. One common issue is over-tightening, which can damage the wire or the connector. Under-tightening can result in a loose connection. Another issue is corrosion, which can occur if the connector is exposed to moisture or corrosive substances. Regular inspection and maintenance can help identify and address these issues before they lead to failures. Seventhly, the importance of regulatory standards and compliance. The use of spin-tight connectors is often subject to regulatory standards and compliance requirements. These standards ensure that the connectors meet certain performance and safety criteria. Compliance with these standards is essential for ensuring the safe and reliable operation of electrical systems. Eighthly, talking about alternatives to spin-tight connectors. While spin-tight connectors are suitable for many applications, other types of electrical connectors may be more appropriate in certain situations. For example, compression connectors may be preferred for high current applications, while insulation displacement connectors, or IDCs, may be used for low voltage signal connections. Ninthly, selecting the right connector. For the correct type of connector, one must consider these factors. The first factor is the current and voltage requirements of the application. The second factor is the wire size and type. The third factor is the environmental conditions, such as temperature and humidity. The fourth factor is the regulatory requirements. The fifth factor is the cost and availability of the connector. Tenthly, talking about future trends in connector technology. Connector technology is constantly evolving, with new materials, designs, and manufacturing processes being developed. Future trends include the development of smaller, more reliable connectors, as well as connectors that can be easily integrated into automated manufacturing processes. By understanding the principles behind spin-tight connectors and how they are properly installed and maintained, it is possible to achieve safe, reliable, and consistent electrical connections.